All right, so now we have a weird word problem. So let's read this and figure it out. On many cell phones with GPS, an approximate location can be given before the GPS signal is received. This is accomplished through a process called triangulation, which works by using the distances from two known points. Suppose there are two cell phone towers within range of a cell phone. The two towers are located 6,000 feet apart on a straight highway running east to west. So, highway, tower one, tower two. Give them little. That's how we know they're towers. And this is 6,000 feet between those two. And the cell phone is north of the highway, so somewhere out in here. So it is closer to the second tower than the first, whatever, but there's our cell phone. So, da 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 da, da 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 da. 50 feet here. 20 feet here. Determine the position of the cell phone north and east of the first tower. So this is the first tower. So north and east. And determine how far it is from the highway. Okay. So we need to be able to find that height, and because it wants the east, we're also going to have to find this partial distance. This height here, though, will meet at a 90-degree angle. So if I can figure out my angle over here, then I can just use right triangle trigonometry to figure out the other two sides. To figure out the angle, though, all I have are three sides of a triangle. We just did this. We're just doing it again. The numbers are a little bit bigger, a little uglier. I need some labels, though, so we'll go ahead with this is alpha, this is beta, this is gamma, so this is C, this is A, and this one is B. Since we are finding alpha, we're going to start with a squared. It equals b squared plus c squared minus 2bc times the cosine of alpha. Let's fill in numbers we know. A is 2420 squared. B is 5050 squared plus C is 6,000 squared minus 2 times 5050 times 6,000 times our unknown cosine alpha. Good Lord. All right. So I know I want to subtract these two because they are being added, so I can subtract them from both sides. Just remember, type it all at once, like the square, or do the square separate and then subtract the numbers over. Like whichever way you're most confident in getting results from the calculator. So 2420 squared minus 5050 squared minus 6,000 squared equals crazy ridiculous negative 55,646,100 square feet. equals, then I have -2 times 50/50 times 6,000 -60,600,000 cosine alpha. Okay. So the cosine of alpha is 55646,100 divided by 60,600,000. And then we're going to do the inverse cosine of that mesh. Right. So inverse cosine of 55646,100 divided by 60600. So our alpha is 23.328 blah 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 degrees. All right, they wanted to know how far from the highway and north and east from the first tower. So how far from the highway is our H? So based on our triangle here, I can say that the sine of alpha, we just found the alpha, is opposite, which is the side we labeled H for height, and then hypotenuse is across from the 90, which is our side B. So H is B sine alpha. So 50/50 times the sine of the thing we just got, 23.328. We got 1,999.7769. So this person is about 2,000 feet from the highway. And then from the first tower going over to the north, I don't know, I guess I'll call that width. But our width is adjacent and related back to the fixed numeral 1, hypotenuse. So that is our cosine. So the cosine of alpha is that new width thing we want over E was the hypotenuse. So W is B cosine alpha. So 50/50 cosine 23.328. And that is 4,637.1749 feet. And feet. So from the first tower, if you go 1,999 feet north and then go 4,637 feet east, you'll be really, really close to that person. You'll only be off by part of a foot, so a few inches, so you'll be there. All right. The other one we have here is the one that was apparently introduced at the beginning of the book. I know, because you guys totally read the book and you remember this, right? Sure. All right, so we got this boat. It leaves the port. It goes 10 miles. Then it turns 20 degrees, which we're going to pretend in math land, like it literally turns, not like it makes a curve. And then travels another 8 miles. And now it wants to know, how far is it from the port? So if I had a boat in the port that's going to try to get to this boat way out there, and it can only go so many miles on the gas it has, I got to know, how many miles is it? So we're trying to find that third side. And up here, the 20 degrees is measured from the direction the boat was going, and then it measures 20 degrees. Now, whether it measures 20 to the left or 20 to the right doesn't matter. We just have a mirror image of the same triangle, and the distance will be the same. So we'll assume they'll communicate correctly so the person can actually get the correct bearing. But here, with that 20 degrees, that means that angle is 180 minus 20, which is 160 degrees. So now I have a side, an angle, and a side. I can't use law of sines. I don't have any pairs, but I can use law of cosines because we want to find the third side. So we need some labels. I guess we'll go with gamma and C. I don't really care about alpha and beta, but across from alpha is A. Across from beta, meaning the side that doesn't touch beta, isn't one of the two sides making up angle beta, is B. All right, and since we're using gamma, we're going to start with C squared equals A squared plus B squared minus 2AB cosine gamma. And we got small numbers. So A is 8, B is 10, and gamma is 160. That is all numbers on the right, so I'm going to crunch all of that on my calculator. Remember, best bet is to type all of it at once. Don't try to break it up into pieces. So 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 160. Make sure you're in degrees. C squared is 284.28. And if you forgot about the squared, just look at this triangle. B is 10, A is 8. Does it make sense to say it's 284 miles from the port? When if I just like stacked A and B with no turns, it'd be 18? Yeah. So now we square root, and again, ignore the negative for the usual reasons. We get 16.86 blah, blah, blah miles. So that's how far the boat is. All right. We're going to cut this one before we look at some of the other crazier work problems.